Hello everyone and welcome to our corporate finance presentation. Today we will be presenting a subchapter of chapter 6, which is volume level cash flows, annuities and perpetuities. Our group consists of 4 members. My name is Pramudito and I'm going to be your first presenter of this presentation. Before we start, we first need to know what an annuity is. We will frequently encounter situations in which we have multiple cash flows that are all the same amount. For example, a common type of loan repayment plan calls for the borrower to repay the loan by making a series of equal payments over some length of time. Almost all consumer loans, such as car loans and home mortgages, feature equal payments usually made each month. More generally, a series of constant or level cash flow that occur at the end of each period for some fixed number of periods is called an ordinary annuity. More correctly, the cash flows are said to be in ordinary annuity form. So now we're going to talk about the present value for annuity cash flows. There are two mathematical formulas that you need to know about the present value for annuity cash flows. The first formula is the annuity present value factor formula. The present value annuity factor is used to calculate the present value of future $1 cash flows. This formula relies on the concept of time value of money. Time value of money is the concept that the dollar received at a future date is worth less than if the same amount is received today. An amount received today can be invested towards future earnings or received sooner utility. For this particular formula, the present value of $1 periodic cash flows is to be used for simplifying the calculation of payments larger than $1. An example of this equation in practice is determining the original amount of a loan. The formula of annuity present value factor is 1 minus open bracket 1 plus r to the power of minus n divided by r. R represents the rate of period and n represents the number of periods. The second formula is the annuity present value formula. The cash flows of an annuity are all the same. We can come up with a handy variation on the basic present value equation. The present value of an annuity of C dollars per period for T periods when the rate of return or interest rate is R is given by C times open bracket 1 minus present value factors divided by R, which equals to C times open bracket 1 minus open bracket 1 plus R to the power of T divided by R. So these are two examples taken from the book, each with a different solution method. Example 1. After carefully going over your budget, you have determined you can afford to pay $632 per month towards a new sports car. You call up your local bank and find out that the going rate is 1% per month for 48 months. How much can you borrow? To determine how much you can borrow, we need to calculate the present value of $632 per month for 48 months at 1% per month. The loan payments are in ordinary annuity form. So the annuity present value factor is annuity present value factor equals open bracket 1 minus present value factor close bracket divided by r, which equals to open bracket 1 minus open bracket 1 divided by 1.01 to the power of 48 close bracket divided by 0.01, which equals to 37.974t. With this factor, we can calculate the present value of the 48 payments of $632 each as present value equals to $632 times 37.974t equals to $24,000. Therefore, $24,000 is what you can afford to borrow and repay. And example 2. Suppose you wish to start up a new business that specializes in the latest of health food trends, frozen yak milk. To produce and market your product, the Yaki Doodle Dandy, you need to borrow $100,000. Because it strikes you as unlikely that this particular fad will be long-lived, you propose to pay off the loan quickly by making 5 equal annual payments. If the interest rate is 18%, what will be the payment? In this case, we know that the present value is $100,000. The interest rate is 18%, and there are 5 years. The payments are all equal, so we need to find the relevant annuity factor and solve for the unknown cash flow. So annual present value equals $100,000 equals to C times open bracket 1 minus present value factor close bracket divided by R. So we get C times open bracket 1 minus open bracket 1 divided by 1.18 to the power of 5 close bracket divided by 0.18, so we get C times 3.1272. Therefore, C equals $100,000 divided by 3.1272, which is $31,977.78. That means that you'll make 5 payments of just under $32,000 each.
So, good morning, everyone. My name is Yoga Putra Prawira, and I will talk about the future value of annuities. So, from the previous explanation, we got the main idea on how to calculate the present value of an annuity. Now, in this section, I will talk about the future value of an annuity. As you may know, there are future value factors for annuities as well as the present value factors. And here the formula for the value of the future value factor for an annuity is annuity future value factor equals to open bracket future value factor subtracted by 1 close bracket and then divided by r, which equals to the open bracket 1 plus r to the power of t subtracted by 1 close bracket and then divided by r. So the t here represents the number of years and the r here represents the amount of the interest rate. So this is the example taken from the book. Suppose you plan to contribute to 2000 US dollars every year to retirement account, paying 8%. If you retire 30 years, how much will you have? So we have the formula as explained before. The annuity future value factor is equals to future value factor subtracted by 1 divided by R. And from the example here, we have 8% for our R, the interest rate, or 0.08. And then we have the 30 years for the T, or the number of years. And we plug in this number into our formula, which results in open bracket 1.08 to the power of 30 subtracted by 1 close bracket, and then we divide it in 0.08, and this results in 113.2832, and this is the future value factor. And now to calculate the future value and of annuity, we calculate it by multiplying the amount of contributed to in every year to retirement account, which is 2000 US dollars, to the future value factor, which is the 113.2832. And this the annuity future value result in 226,166.42 US dollars. And that's all from me. And in the next slide, it will be discussed by my friend Adrian. Thank you for listening.
Hello, my name is Andy Adrian and I will continue this presentation. So my part will be a note about annuities due and perpetuities. So let's start it, and then the basic question will be what is the definition of both these things. So the first one is annuity dues. Annuity due is an annuity for which the cash flow occur at the beginning of the period. So almost any type of arrangement in which we have to prepay the same amount each period is an annuity due. And then how to calculate the present or future value of an annuity due. So there is an easy way to calculate the present or future value of an annuity due. If we assume cash flow occur at the end of each period, when they really occur at the beginning, then we discount each one by one period to many. We could fix this by simply multiplying our answer by 1 plus r, where r is the discount rate. And in fact, the relationship between the value of an annuity due and an ordinary annuity is like this. An annuity due value equals to ordinary annuity value times open bracket plus open bracket 1 plus r close bracket. This formula works for both present and future value. So calculating the value of an annuity due involves two steps. The first one is calculate the present or the future value as though it were an ordinary annuity. And second step is to multiply our answer by 1 plus r. And then perpetuities. What is perpetuities? It's an annuity in which the cash flow continues forever. And sometimes perpetuities also called console, particularly in Canada and United Kingdom. And because perpetuity has an infinite number of cash flows, we obviously can compute its value by discounting each one. Fortunately, valuing a perpetuity turns out to be the easiest possible case. The present value of perpetuity is simply PV, it means perpetuity equals to C divided by R. For example of this is example question is this one is an investment offer perpetual cash flow 500 every year, and then the return required on such an investment is 8%. And then what is the value of this investment? So the value of these perpetuities, we can search it by using the formula C divided by R. So $500 divided by 0.08 because 8%. So, okay, it's equals to 6,250. So the value of this perpetuity is 6,250. That's one the example of perpetuities question. Okay, so the next one is the summary annuity and perpetuity calculation. So we start from the symbol. PV means present value. FVT is future value. R for the interest rate of return, and so on. T for the number of periods, and the C for the cash amount. And then how to search for the future value of C is FVT equals to C times open bracket, 1 plus R, close bracket, power of T minus 1, close bracket, divided by R, close bracket. So a series of identical cash flow is called an annuity. And the term of that is in the PPT is called the annuity future value of factor. And then if you want to search the present value of C, you can use this formula, and then you can see that the term of this formula is called the annuity present value factor. And the last one is present value of perpetuity of C per period. So if you want to, this is the simple one, is the PV equals to C divided by R. So it's a perpetuity has the same cash flow every year forever. So yeah, thank you.
Hello, my name is Fikri Aftansha, and now I will explain about the growing annuities and perpetuities. First, I will explain about the growing annuity. The growing annuity is a growing stream of cash flows with a fixed maturity. Below are the formula of the growing annuity. This one is the formula of the growing annuity, and below are the formula of the present value of growing annuity. The PV is stand for present value, C for payment per period, and R for interest per period, G is for growth per period, and N is for number of periods. This one is the formula for the present value of growing annuity. Okay, and now this is the example of growing annuity problem solving. A retirement plan offers to pay $20,000 per year for 40 years and increase the annual payment by 3% each year. What is the present value at retirement if the discount rate is 10%? Okay, so we already get the number right here from the 20,000. We have the payment per period is the 20,000, and the discount rate are 10%. So and the annual payment will be increased to 3% for each year, and the number of period is 40 years. And from the formula, we can get the present value for 265,000 and 121.57. Okay, And now I will explain about the growing perpetuity. The growing perpetuity is a growing stream of cash flows that lasts forever. Below are the formula of the growing perpetuity. This one is the formula of growing perpetuity, and below are the formula for present value for growing perpetuity. PPV is stand for present value, C is for payment per period, R for interest per period, and G is for growth per period. Okay, this is the example of the growing perpetuity question. The expected dividend next year is $1.30, and dividends are expected to grow at 5% forever. If the discount rate is 10%, what is the value of this promised dividend stream? We already get the number from this question, so we just need to put them into the formula, and we get the present value for $26. And okay, that's all for me. Thank you.